Today, the conventional line separating a standard commercial software update from a localized tactical strike is rapidly vaporizing. For decades, national defense networks were built and maintained by a very specific type of legacy contractor, companies that specialized in welding steel, engineering bespoke ballistics, and assembling heavy hardware in secure facilities. But the logistics of modern defense have migrated. The scale of computing power required to manage global intelligence now demands massive database systems and high-performance artificial intelligence chips, infrastructure that legacy weapons manufacturers simply do not have. Governments are instead forced to rely on commercial big tech platforms. This pivot is anchored by a multi-billion-dollar joint cloud computing and AI initiative known as Project Nimbus. Awarded to top-tier Silicon Valley firms, this contract bypasses traditional procurement to deliver advanced machine learning capabilities and massive data storage solutions directly into the hands of government agencies and military defense departments. These companies often market these services to the public as standard enterprise IT upgrades. In reality, consumer AI models, trained entirely on public data, are being repurposed for border surveillance and tactical battlefield management. The exact same server farms routing consumer internet searches and email traffic now operate as the foundational command layer for state military power. Operating a cloud environment for a defense network requires a highly specific technical architecture, one that goes far beyond basic file storage. This blueprint starts with a central commercial software engine at its core. From here, defense networks rely on 5 key technical pillars. The first is high-density facial recognition and spatial AI, using advanced computer vision to track movement across physical borders in real time. Second is predictive intelligence. Machine learning models analyze historical data and social media feeds to forecast security threats. Third is edge computing, deploying portable cloud servers directly into active field operations to process data on-site without centralized server farms. The fourth pillar integrates autonomous systems. Real-time sensor data is fed directly into uncrewed aerial vehicles and ground units to accelerate target identification and automate logistics. This means targeting calculations are processed continuously in the air, dynamically adjusting flight paths based on the sensor inputs. Finally, the fifth pillar encases the entire system: elastic cloud storage. This provides virtually infinite encrypted capacity to index millions of hours of mass surveillance footage and telecommunications intercepts. Ethicists classify this specific architecture as dual-use technology. A database designed to optimize hospital patient care can be reconfigured within the exact same software engine to track human populations with military precision. Because the commercial and tactical codebases are identical, the consumer enterprise tool and the lethal targeting system are technically indistinguishable at the engineering level. The friction generated by this integration surfaced within the workforce responsible for the code. Defense contractors hire personnel explicitly to design weapons. Silicon Valley, by contrast, built its culture around open-source collaboration, digital democratization, and ethical AI development. The execution of Project Nimbus triggered internal rebellion across major tech headquarters. This chart highlights the core of the code ethics conflict. Developers discovered that proprietary code they wrote for commercial search engines was being rerouted into state surveillance and defense architecture without their explicit consent. In response, thousands of software engineers, product managers, and data scientists circulated internal petitions and staged coordinated walkouts, demanding the immediate cancellation of these defense contracts. Tech executives moved quickly to implement zero-tolerance policies regarding political activism on company premises. Internal communication channels were heavily moderated or completely shut down, and dozens of veteran engineers were terminated for participating in the protests. The innovation hubs that defined the early commercial internet have transitioned into controlled entities aligned with sovereign defense priorities. Government strategists view these internal ethical debates as secondary to the pragmatic realities of national survival. When we map the ethicists' concerns against the state's strategic arguments, 3 major defense pillars emerge. The first argument is technological sovereignty. Strategists argue that if democratic nations fail to integrate advanced commercial AI and cloud computing, rival foreign powers will outpace them in defense capabilities. The second argument is known as the void dilemma. If domestic tech giants refuse to fulfill government contracts, second-tier contractors or international firms will step in to take the multi-billion-dollar deals, firms that likely operate with zero ethical oversight. The third dynamic is economic interdependence. Consumer markets saturate, and broad economic volatility threatens hardware sales. Government defense contracts offer tech giants reliable, multi-billion-dollar recurring revenue streams that insulate them from these market fluctuations. This leaves democratic societies caught in a rigid paradox. They expect ethical purity from their leading tech innovators, yet rely entirely on the weaponization of those exact innovations for their geopolitical stability. Project Nimbus serves as a template for a system where national defense priorities dictate the internal policies and development cycles of private firms. A shift in capital is already visible as investment flows towards a new wave of defense-first AI startups. These startups are bypassing the traditional route of developing consumer software, designing their architecture specifically for military contracts from day one. Simultaneously, legacy tech corporations are lobbying for federal AI safety standards, a textbook push for regulatory capture. These incoming regulations are structured to heavily favor large, heavily vetted government contractors, while simultaneously placing compliance burdens on independent open-source developers that effectively price them out of the market. Meanwhile, legal battles are escalating in the courts to determine whether software engineers have any whistleblower protections when exposing the defense applications of proprietary code they helped write. The struggle over who owns and controls AI architecture extends far beyond software engineering. It will define whether technology serves human interests, corporate profit, or state surveillance.